Alright, this video we are going to talk about some function, logarithm function. You know, trying to graph logarithm function. See, to draw this is a little bit different, not very much, but I mean it's better to do this way. You know, we have like give you a simple one. Y is equal to log base 3 log of x with the base 3. So let's graph this function. You know, we give value to x, we find y. It's a function, you know. Remember that I talked about that before. If you have a function like this, if you draw a vertical line, I mean, it will intersect this line. This is x and y, and it intersect in one point, which we can see this is a function. Whatever, you know, we have like this from here anywhere. Just you have the one x value for every any other. But if you have something like this, if you draw a vertical line, you see 2 for x here, whatever it is, you know, we have 2 values for y. This is not a function. No, not function. So let's graph this one. So what we do, you have to choose the x. You know, x, they say log y, for example, 2. 2 to the power of something is going to be like 2 to the power of a. 2 to the power of a is going to be y. Y actually is the result of the exponential number. So x here is actually 3 to the power of something, you know, is going to be x. So we give value to x. Okay, see, x and y. Y is equal to log base 3 here. So how we graph this? We got to give it some x value. I mean, for simplicity, we can give any x value to any value to x and find y. You got to have the calculator, but for drawing, we make it easier. We say that we are going to make x something that if you raise this one to an integer, negative integer or positive integer, is going to be x. So if you raise 3 to the power of, for example, minus 2, 3 to the power of 2 is going to be equal to x. X is, you know, we suppose that x is 3 to the power of 2. This is here is 2. Okay, minus 2. And the second time we say minus 1, and then we give all 0, everything, you know, 1 plus 2, and we give value. We actually choose an integer that either start from minus 2 and up to plus 2. So what is going to be, x is 3 minus 2. So what it means is log of 3 to the power of 2 You say x is this one, so if we put x there, x is going to be 3 to the power, write it here, 3 to the power of 2 minus 2 is going to be 1 over 9. Okay? So the result is going to be 3 to the power of minus 2 is going to be 1 over 9. So let's get another one. 3 to the power of minus 1. Y is equal to log of base 3. But if 3 to the power of minus 1 is 3 to the power of minus 1 is 1 over 3. Okay? Let's write it here, 1 over 3. To the base is 3. So what's going to be the exponent of 3? So it's going to be 1 over 3. It's going to be minus 1. 3 to the power of minus 1 is going to be 1 over 3. And then you say 3 to the power of 0. Y is equal to 3 to the power of 0 means this is 3 to the power of 0. This is actually the result of, if we raise this one to this one, it's going to be this one. We raise the base to this power, and it's going to be this one. We raise this one to the power, and it's going to be 1 over 3, as we talked about it earlier. So then we say 3 to the power of 1. Y, this one here, log of y, log of 3. So 3 to the power of 1 is what? This is 3 to the power of 0 is going to be 1, and 3 to the power of 1 is going to be 3. So what you have to raise this one to the power of 1 to get 3. So y this is going to be 1, 3 to the power of 1. So this one is equal to 1. Log of 3 to the power of 3 is equal to 1. Okay? And if we write 3 to the power of 2, let's write this one too. Y log 9 base 3 is equal to 2. 3 to the power of 2 is going to be 9. No, we have the points now. See, we have the points. We have the points. So what is going to be like? We have the point 1 over 9, 1 over 3, 1. 3 to the power of 0 is going to be 1, 3, and 9. 3 to the power of 1 is going to be 3, 3 to the power of 2 is going to be 9. So we have this point, if y is 1 over 9, x, y is going to be minus 2. And this one here, if 1 over 3 is going to be minus 1. And if this one is, the third one, if x is 1, y is going to be 0. And for this one, if 3 and 1. And the last point is 9, 2. See, we have x, the point has got to have x and y. Any point, if somebody tells you that, you know, just give you x coordinate and doesn't give you y coordinate, you cannot make a point. You cannot draw a point or locate a point. So let's locate this point. It plus 1 over 9 is going to be, see, y is going to be minus 2. See, y is going to be minus 2. Let's start from here is better. 9, if you have 9, this is 5, 6, 7, 8, 9. 9, 2. It's going to be this point here. 9 and 2, and then 3 and 1, and then 3 and 1 here, and then 1 and 0, 1 and 0 here, and then minus 1, 1 minus 1/3 means here somewhere here, okay, 1/3. See this one, we're talking about this one. 1/3 is going to be minus 1, it's going to be here, the next point is going, and then 1/9 is going to be minus 2, is going to be something very close to this one. So if we connect these, we are going to get something like that, and this is going to get closer and approaches 0, but it doesn't get 0 until infinity. So actually it's undefined. So we put all these points here, 3, 1 and 1, 0, and all these, the number that we find out, 1/3 minus 1, and this one 2 minus 2 is going to be 1/9. So that's the one way to draw this, to graph this function. So let's see, this is the inverse of the exponential, the exponential function. The reason I'm going to say this, let's talk about that one too also. Suppose that 3 to the power of x, y is equal 3 to the power of x. I said, this is the inverse of this one. Let's draw this one. We talked about it earlier, and we say x and y. We give value to x, for example, minus 2. 3 to the power of minus 2, y is equal to the power of minus 2 is going to be 1/9. Minus 1 is 3 to the power of, this is 3 to the power of x. So we just write this to the power of 1, y is this one, and 1/3. Because we are using the same example, so to show you that this is inverse of this exponential function. So inverse of. So if it's 0, 3 to the power of 0 is going to be 1, 3 to the power of 1 is going to be 3, 3 to the power of 2 is going to be 9. So let's graph this. So what we do, we find the point. We found the point already. The points are minus 2, 1, 9, y is y, and 1/9, because if we give value to x, y is going to be 3 to the power of minus 2 is going to be 9. And then minus 1 is 1/3, and then 0, x 0, y is going to be 1, and then x is 1 is going to be 3y, 3, y is going to be 3, if it's 2 it's going to be 9. So let's locate this point. We start from here, or whatever, from here. Minus 2, we have 1 and 9. And this is 1/9, almost 1/10 of it, it's going to be here. Okay, and then we have minus 1 is 1/3. This one, if you divide it by 3, is going to be 1/3. It's going to be a little bit more here, and then 0, 1. X is 0, y is 1. It's going to be this point here, and this is on this axis. This is 0, 0 here, on y-axis, and 1 1 and 3. 1 and 3. It's going to be this point, and then 2, 9. 2, 9. 9, this is 5, and it's not going to be somewhere up there. So we connect these points. Okay. So this is the inverse of this one. This is y is equal to 3 to the power of x. And this one is log 3 log of x to the base 3. See, these are inverse of each other. So I just want to let you know that the inverse of that is going to be this. And so let's look at an example here that give you some good examples. See, to the power of let me see where I just put this here. Okay, let's solve no, let me clear this one. And we leave this one. And we are going to say that if we have something like y equal log of 3x to minus 3, for example. So what is going to be the what this one look like? See, this is not very. This is also complicated. You know, if you give some value to x, like if you give, you know, I mean, it's a little bit easier to do it this way. That you x minus 3 is going to is equal to 0. X is going to be 3. So what we say here that if we shift this one 3 to the right, 3 to the right, then we're gonna have if we move this one with minus 3 of this one, you know, we add a minus here, you know, log of x minus 3 to the base 3. When we are gonna draw it, what we do, the best way to transform this, one of the ways is to transform this. It's sometimes you give value to x here and it's hard to find, and you have to calculator to find, you know, this. If you give x 9, it's going to be 9 minus 3 is going to be 6. You put it in the calculator, the log of 3, the log of, for example, 7 here is 4, say log of 4 to the power 3, you put it in the calculator, you find the answer. But for drawing, it's easier to say this one. See, we choose 2 points here, 2 points on this log of this one. This is log of y is equal to log of this. Okay. If we choose 2 points, 1 and 0, and the other point, this one, 3 and 1. See here? We point. See, these are the points on this. If x if x is 1, y is going to be 0. So 3 uh, because you know, let me talk about this first, and then we go to the we choose this point 1 and 0, and this point 2, and then if you say if you shift this one x 3 to the right, means if you set it to 0 again, x to the 0 to the right means here now this is going to change. This is for this function, and if we change this one to, let's say we use x is equal to 3, x is equal to 3. Okay, we shifted 3 units this way. So everything of x coordinate is going to shift this. So it's going to be 3, you add them up, 3 plus 1, and then 0, and then you add this one, 3 plus 3 is going to, with 1 y. The y is 1 and x is, so this is going to be 4, 0, the point, and 6 and 0. 6 and 1. If you draw this one, say 4, 1 point, 4 and 0, 1 point, and then 6 and 1. 6 and 1. It's going to be, this is 6 and it's going to be 1 here. So actually, and then where do they go? If you have to find some numbers too. But we noticed that if we know the vertical asymptote, then we know where this graph is going to look like. So actually what you do, you set this one to 0 and x is equal to x is, this one x is going to be vertical asymptote. So it's going to be let me show you with this color. No, 3, I'm sorry. X is equal to 3. Let's do it with this. Okay, this is the vertical asymptote. So this has to go, it is not going to get to 0. If you give x, this one is going to be 0. You know, it's against the rules of the log that this cannot be 0. Okay, so what's going to happen, this is going to be coming this. This is y is equal log of x minus 3. X minus 3. Okay, let me bring it here. Y log of 3 to x minus 3. So you see that 3 units shifted this way. Now you say that let's solve another one. That is, this one is this one is going to be pretty much the same. So what is that? We say that if y is equal to log base 3 x plus 3, what's going to happen? What is going to be, what does it look like? Okay, so x plus 3 is equal to 0, x is equal minus 3. So the vertical asymptote here is going to be -3. Okay, now you say what is that? How do we find it? So we set this one to 0, you say x is equal to -3, so this is actually show where your vertical asymptote. So if you have 2 points here, like the same point, 1 and 3 and 1, x3 and y is 1, see we are going to make it to this one here. We shift this one to the minus, this is going to be -3. So all the x's here, this is going to be -3. -3 plus 1 is going to be -2, 0, and this point is going to be -3 plus 3, 0, 1. Now let's draw this. -2 is 0, and then x0, y1, this one here, the point is going to be here, and if you it's going to be like that. If you want the real point up to some point that the graph would be more accurate, you know, to locate that point. So you see that it's easy just to this one has moved 3 to the right, and this one is 1, 2, 3 to the left. The point here is 3 to the left, but we have to have 2 points in order to graph it. Like, see this one here, we choose these 2 points, this point A, this point A, and this point B. So the B prime is here, and this point is 3 x and y is 1. So actually these 2 points, the 3 -3, 3 minus 3 is going to be 0, so it's going to move this point here is going to go to, is going to be 1. So actually, you know, moving this, but so I hope you understand what I'm trying to say. This is show the vertical asymptote. If you set this one to 0, it shows where it approach this line, but it never get to that line. So let's we are later in things, you know, we are going to talk about the vertical horizontal asymptote, but we talk about the domain and the range of that later, because, you know, the domain is going to be, see, lowest value domain is the low value of x, and highest is the lowest highest value of x. So we in next video we are going to talk about more of these examples. We are going to tell you